Good morning. Last time we started to talk about Nth-Taylor polynomial. For f at a. That's just infinite the first nth term of the infinite series when a function is infinitely many times differentiable. Let's continue with example. Find the third Taylor polynomial for f of x equals x to the 1 over 3 at x equals 3. By its definition, third Taylor polynomial is summation k equals 0 to 3, k's derivative at 3 over k factorial times x minus 3 to the k power. That means we have to think about f of 3 and f prime of 3 and second derivative of f and third derivative of f at 3. F of 3 is 3 to the 1/3. I just plug it here. And f prime of x is derivative of this one. That is 1 over 3 x to the minus 2/3. So f prime at 3 equals 1/3 times 3 to the minus 2/3. What is this? This one is 3 to the minus 1 power. So that is 3 to the minus 5 over 3. And second derivative of f is 1/3 times minus 2/3 times x to the minus 5 over 3. Therefore, f double prime of 3 is minus 2 over 9 times 3 to the minus 5 over 3. And third derivative at f is minus 2 over 9 times minus 5 over 3 times x to the minus 8 over 3. Therefore, third derivative at 3 is minus minus, so it makes plus, and 10 over 27, 3 to the minus 8 over 3. What we've been calculating is this part. Let's expand this out. We just elaborate what this means. Then third Taylor polynomial of x is f of 3 plus f prime of 3 over 1 factorial times x minus 3 plus second derivative at 3 over 2 factorial times x minus 3 squared plus a third derivative at 3 over 3 factorial x minus 3 cubed. So f of 3 is a 3 to the 1/3 plus f prime of 3 is 1/3 times 3 to the minus 2/3 x minus 3 plus f double prime of 3 was minus 2 over 9 times 3 to the minus 5 over 3 times 1 over 2 factorial is 2 times x minus 3 squared plus third derivative of f is 10 over 27, 3 times minus 8 over 3 times 3 factorial in the denominator will be 6. So 1 over 6 x minus 3 cubed. You should be able to calculate it. I won't go through how to do apply exponential rule for this. These will cancel each other. And what I'm trying to say is you can simplify further. After you go through all those, you will get 3 to the 1/3 plus 1 over 3 to the 5 over 3 times x minus 3 minus 1 over 3 to the 11 over 3 x minus 3 squared plus 5 times 1/3 to the 20 over 3 x minus 3 cubed. The next one is find P1 of x or f of x equals natural log of 3x at x equals 1. So by its definitions, the first Taylor polynomial is from summation k equals 0 to 1. K derivative at 1 over k factorial times x minus 1 to the k power. So we evaluate at 1, then that will be natural log of 3 times 1 equals natural log of 3. And f prime of x equals 3 over 3x, which is 1 over x. Therefore, f prime at 1 equals 1 over 1, which is 1. When we elaborate this summation notation, is f of 1 plus f prime of 1 over 1 factorial times x minus 1. F of 1 is natural log of 3 plus f prime is 1. 1 over 1 factorial is 1. So x minus 1. Do you have any question? Find P2 of x for f of x equals cosine of 5x at x equals 5 over 3. So by the definition of second Taylor polynomial, it is k equals 0 to 2, k derivative at pi over 3 over k factorial times x minus pi over 3 to the k power. So we start by evaluating at pi over 3, then that's cosine of 5 pi over 3. So what is this? This one is 0 and 2 pi, which is 6 pi over 3. And 5 pi over 3 is in the third quadrant. And the reference angle is pi over 3. On the right side, cosine is positive. Therefore, we can say that that's cosine of pi over 3. So that is 1 over 2. I'm thinking about 1 to square root of 3. This one is pi over 3. And what is f prime of x? That is minus 5 times sine of 5x. And then f prime of pi over 3 equals minus 5 times sine of 5 pi over 3. On the fourth quadrant, sine is negative because that is defined by y over r. Y is negative, so sine is negative. So this time that equals minus 5 times minus sine of pi over 3. So minus minus will become plus. So 5 times sine of pi over 3 is square root of 3 over 2. Let's do the second derivative. We differentiate the first derivative, then that's minus 5 times 5 times cosine of 5x. So that's minus 25 times cosine of 5x. Second derivative at pi over 3 is minus 25 times cosine of pi over 3. So that's minus 25 times cosine of pi over 3. We already know why that becomes like that. That's minus 25 times 1 over 2, so over 2. So the P2 of x, that can be written as f of pi over 3 plus f prime pi over 3 over 1 factorial x minus pi over 3 plus f double prime pi over 3 over 2 factorial x minus pi over 3 squared. Must be written as 1 over 2 plus 5 square root of 3 over 2 x minus pi over 3 plus minus 25 over 2 times 1 over 2 x minus pi over 3 squared. So when we simplify it, that becomes 1 over 2, 5 square root of 3 over 2, x minus pi over 3 minus 25 over 4, x minus pi over 3 squared. Any question? It's quite mechanical process. Find the Maclaurin series, Maclaurin polynomial, P1 of x for f of x equals 1 over 4x plus 8. So P1 of x is what? So this is a Maclaurin polynomial. That means center at x equals 0, right? So we have to evaluate at 0. So f of 0 plus f prime of 0 over x over 1 factorial times x. F of 0 equals 1 over 4 times 0 plus 8, which is 1 over 8. And f prime of x equals the denominators squared. And the numerator is minus 4. So what is the value at 0? That is minus 4 over 8 squared, which is minus 4 over 64, which is minus 1 over 16. So f of 0 is 1 over 8 plus f prime of 0 is minus 1 over 16 x. Do you have any questions? Use the formulas to solve the problems. So what I'm trying to do is stating the Maclaurin series expansion. Those are the things you have to remember very clearly. As we learned last time, e to the x is summation n equals 0 to infinity x to the n power over n factorial. And sine of x equals summation n equals 0 to infinity minus 1 to the n power over 2n plus 1 factorial x to n plus 1 power. We already did it, verified it last time. And cosine of x equals summation n equals 0 to infinity minus 1 to the n power over 2n factorial times x to n power, which is an even function. Natural log of 1 plus x is, of course, n equals 1 to infinity minus 1 to n plus 1 power, x to n power over n. So of course, you can relate that with the geometric series to derive. Tangent inverse of x is summation n equals 0 to infinity minus 1 to the n power x to the to n plus 1 over 2n plus 1. Remember, tangent function is a odd function. So odd degree terms will survive, but different from sign, there is no factorial in the denominator. Hyperbolic sine of x is defined as e to the x minus e to the minus x over 2. And hyperbolic cosine of x is e to the x plus e to the minus x over 2. It is not the Maclaurin series expansion, it's a definition, but you can use the result of e to the x to figure out what that is. All of them must be clearly remembered. Make sure that you're not confused with the formula. When I say Maclaurin series, that is Taylor series centered at 0. This is important. This one cannot be applied to the center at x equals a, which is not equal to 0, which means general Taylor series. That means when we consider the Taylor series expansion at 3, you cannot replace this part by x minus 3 to the nth power. You have to calculate it term by term. Find the first 4 non-zero terms of the Maclaurin series. The first problem is f of x equals 3 times e to the 4 x to the 5th power. We consider Maclaurin series expansion. While we cannot apply the Maclaurin series expansion related formula when the center is shifted to other place, we can still use Maclaurin series expansion when the variable part is not x, like this. So we have e to the x equals summation n equals 0 to infinity x to the nth power over n factorial. That is the formula. This time, what happens here is we are still thinking about the expansion around 0, but this variable is replaced by 4x to the 5th power. And so we can still utilize this formula by replacing x by 4x to the 4th power. So 3 times e to the 4 x to the 5th power can be written as 3 times summation n equals 0 to infinity 4 x to the 5th power n over n factorial. So what can we say about this? 3 times we start to plug in, then that will be 4x to the 5th power 0 over 0 factorial times plus 4x to the 5th power n equals 1 over 1 factorial plus 4x to the 5th power squared over 2 factorial plus 4x to the 5th power cubed over 3 factorial plus da da da. So it suggests the first four non-zero terms. So it becomes 3 times, what did I say about 0 factorial? 0 factorial is 1. 0th power is 1. So the first term is 1 plus 4 x to the 5th power plus we distribute the exponent, then that'll be 60 x to the 10th power over 2 plus distribute the power, then that will be 64 times x to the 15th power over 6 plus da da da. So we divide by 2 on the numerator and denominator, then this one is 2 and this one is 32 and this is 8. So that is 3 times 1 plus 4 x to the 5th power plus 8 times x to the 10th power plus 32 over 3 x to the 15th power, da da da. So what is the first 4 terms? Three plus 12 x to the 5th power plus 24 times x to the 10th power plus 32 x to the 15th power. I just did distribution. Do you have any question? Let me return your quiz and then you will take a mini makeup quiz.